Back. Problem 6, section 10.4. Find the area inside the larger loop and outside the smaller loop of the lemicon r equals half plus cosine theta. So let's look at r equals half plus cosine theta. Let's first graph it. Take angle theta 0, pi over 3, pi over 2, 2 pi over 3. So notice I have taken multiples of pi over 3 just so I get some reasonable numbers to work with. So I get this curve. All right. So notice, looks like my curve at 0, angle 0, I'm 3 pi over 2. All right. So angle pi at angle 0, I start here. Looks like on the left, I go here until here. The moment I'm below, I start going inside. So the moment this is 2 pi over 3, I have hit 0. Below 2 pi by 3, I start going negative length. Therefore, I'm back to the right. Okay? Until I come here and I'm here again. All right, so what is this region? This region corresponds to my angle 2 pi over 3 to 4 pi over 3. So what happens at 2 pi over 3? I'm angle 0, pi I'm negative, 4 pi over 3 I'm 0. So I start here. Instead of having a picture here, I'm here because the lengths are negative. So that piece corresponds to angle 2 pi over 3 until 4 pi over 3. The outer piece starts from angle 4 pi over 3, goes on until 2 pi over 3. Notice, what did I say? 4 pi over 3. But 4 pi over 3 is bigger than 2 pi over 3. That's why we replace it by negative 2 pi over 3. Negative 2 pi over 3 to positive 2 pi over 3 gives me the outer curve. Whereas 2 pi over 3 to 4 pi over 3 gives me the inner curve. So area between these two curves is given by, first, the outer curve, negative 2 pi over 3 to positive 2 pi over 3. So instead of saying 4 pi over 3, which is bigger than 2, greater than 2 pi over 3, I'm taking an analogous angle, negative 2 pi over 3, that is less than 2 pi over 3. So that's the outer curve's area. I'm taking away the area within the smaller curve. This corresponds to angle 2 pi over 3 until angle 4 pi over 3. All right. The rest is straightforward. That's your curve r square over 2. R squared over 2. The integrand in both the cases is the same, so only the limits are different. Therefore, let's calculate the integral, right? So simplify, get the half outside. This is a complete square, 1/4 plus cosine theta plus cosine squared theta. Cosine squared in turn is using some angle formula, 1 plus cosine 2 theta over 2. So integral, you see 1/4 plus a half is 3/4. So cosine and cosine 2 theta over 2. So notice that 1/2 I have added to 1/4 to give you 3/4. So finally, integral of all this, 3/4 is 3/4 theta. Notice that 2 I'm multiplying to the denominator. Cosine, integral of cosine is sine. Integral of this cosine is also sine, but that 2 I need to divide, which gets me a 4 times a 2 from outside gets me an 8. So that is the integral of this entire expression. So our original, this is not length, it's area, mind you. Area, so I should fix that. It should be area. Okay. It should be area. All right. All right. So area is the same integrand but different limits. We calculated the integrand and this is the integral evaluated at the limits. Now this takes some careful thought. Sine 2 pi over 3, you see. So that's when theta is 2 pi over 3 minus evaluate at negative 2 pi over 3. Do you notice? Now for this one, first evaluate at 4 pi over 3 and there is a negative because I'm subtracting. And a subtraction evaluated at negative 2 pi over 3. So notice because this is being subtracted along with a subtraction, I'm actually adding this evaluation, hence the 2. This 2 is the first evaluation at 2 pi over 3 minus the second evaluation at 2 pi over 3. So therefore I have 2 of these. Now what about some places I have 8 pi over 3. Where did that 8 come from? Well, it's 2 theta. When theta is 4 pi over 3, twice of that is 8 pi over 3. All right. Likewise, I have theta 4 pi over 3. So I have a 4 pi over 3 here, a 4 pi over 3 here. Notice, main thing to note, sine of 8 pi over 3. 8 pi over 3 is concurrent with 2 pi over 3. That is, they represent the same point. Therefore, sine is going to give you the same value. On the other hand, 4 pi over 3 is on the third quadrant. 2 pi over 3 is on the second quadrant. So, sine of these two will be opposites. Sine 4 pi over 3 will be negative sine 2 pi over 3. So using this information, I can replace where I see 8, I'll replace 8 by 2. Where I see 4, I'll change the sign itself, negative. The negative, because sine is an odd function, the negative comes out. And upon all these simplifications, I get pi over 4. So you see, those are the only ones without sign, without trigonometric function involved. Simplify all that, you get pi over 4. Simplify all the signs here, reduce them to 2 pi over 3. You get 3 halves of it. Substitute finally. Sine of 2 pi over 3 is root 3 over 2. So in all, pi over 4 plus 3 root 3 over 4. Let's see whether this is correct. Pi over 4 plus 3 square root 3 over 4. Hope it works. Yes, it is correct. And that completes all the problems from section 10.4. We'll continue next section in our next video. Until then, bye.